Okay. Okay, sorry about that. All right. So if I go back to this in 26, all right, that and that are the outside angles. So that means we can take those angles, 2x plus 10x minus 6, and set it equal to 180. 2x plus 10x is 12x. To get rid of the minus 6, I would add 6. So 12x equals 186. Divide by 12, and I get 15 and a half or 15.5. Yes, sir. Oh, my bad. 90, 96. No, x is 8. All right. Now, when I look at 27, all right, please realize also the vertex angles are bisected. So if that's 5x minus 1, that one's also 5x minus 1. So 5x minus 1 plus 8x equals 90. 5x and 8x is 13x. Add the 1, you get 91. And x equals 7. All right. The last one, 28. These are the non-vertex angles, so they are congruent. So I'll set 4x plus 13 equal to 5x minus 15. Subtract 4x and add 15 to both sides. X is 28. Plug it in. 4 times 28 is 112. 112 plus 13 is 125. This one's also 125. All right. If this is y, then this is also y. Angles of a triangle add up to 180. So I'm going to take those two angles, y minus 9. I'm going to add y and set it equal to 55. Because 180 minus 125 is 55. 1y and 1y is 2y. Add the 9, you get 64. And y equals 32. All right. Does anybody else have any questions from either 6-4 practice, 6-5 practice, or 6-6 practice? All good? Okay. So you guys are B. You'll be taking the quiz on Monday. Virtual. Oh, can I go over 28 and 26 on 6-4? Absolutely. I'm going to go back here. I'm going to go to 6-4 practice G. And I'm going to discuss 26 and 28. All right. Let me chop that. All right, so there's that. Bring that over here. Oh, do it that way. All right. All righty. So, start with 26. According to the diagram, opposite sides of a rectangle are congruent. So x equals 4y. 2y equals 3x minus 10. Since x is isolated, I can substitute that in the second equation. 2y equals 3 times 4y minus 10. 2y equals 12y minus 30. 10y or negative 10y equals negative 30. Y equals 3. If I plug that in, 4 times 3 is 12. Nope. Something I did. X equals 4y, 2y equals 3x minus 10. So 2y equals 12y minus over. X equals 4y. 2y equals 3 times 4y minus 10. 2y equals 12y minus 10. Negative 10y equals negative 10. Y equals 1. If y equals 1, this side would be 4. So x would also be 4. If I plug that in to verify, 3 times 4 is 12. 12 minus 10 is 2. 2 times 1 is 2, so I'm good to go. All right. And then 28, rectangle DVEO with diagonals DE and OV. DVEO. Okay. So basically with the rectangle, like we talked about on Monday, we would use those sides are congruent, properties of parallelogram. Those angles would be congruent, definition of a rectangle. That side would be congruent, all right, by shared side reflexive property. And the triangles would be congruent by side angle side. All right, so basically you start with the rectangle because it's given. You would then say DO is congruent to VE, properties of parallelograms. You would then say angle O is congruent to angle E, definition of a rectangle. OE is congruent, slide it up. OE is congruent to OE, reflexive. Triangle OVE is congruent to triangle BEV. All right. By side angle side. All right, so that takes care of 26 and 28 from 6-4. Any else? I got all day. I can do this all day. Nothing. Couple snow days after 7 weeks of no school. You're all kind of just going with the flow. I feel it. It's been a long year. Talking about 70. All right. Everybody's good? Everybody playing the home game good? All right, if you do have any questions about any of the others, feel free to try to comment after that. Let us discuss a couple other things. Let me do the hole punching. There. Boom. 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 Shotgun. Lock it. There we go. All right. 1 and 2, work on those, please. 1 and 2, work on those. For those of you playing the home game, we're just doing a 1 and 2. Determine if the following universal statements are true or false. If false, give a counterexample. Remember, if it's true, you don't have to do anything, you just write true. All right. Now, yesterday we did it with the flow chart. Today we're just going to show you with Venn diagrams another way you can perceive these types of problems. All right. So there's the bigger set, and then there is what would be the subset. All right. So whatever follows the R goes outside, quadrilateral. I personally wouldn't do it this way. I would do it the other way, but everybody's different. And then in here would be isosceles trapezoid. Is that an accurate diagram or isosceles trapezoid subset of quadrilaterals? Yeah. The easier way of doing it is how many sides in a trapezoid? 4, which is the definition. So that, my friends, would be true. All right. Now, all parallelograms are rectangles. That, of course, is false. All right, that of course is false. Now, when you do your counterexample, you draw the sketch of your parallelogram. Okay? And then you indicate what separates parallelograms from rectangles. Rectangles, all their angles are how many degrees? 90. So you can make this like we did yesterday, 80 degrees. Now, here's the thing. You have to show the person that you know, all right, that that's a parallelogram. The easiest way to do that is the definition. You put parallel sides. All right. However, you can also label it with any properties you want. For example, if you want to label the opposite sides congruent, you can do that. Opposite angles congruent and consecutive angles supplementary. You don't have to do all of it. You just have to do one of them. Or you can draw in your diagonals for those of you that are overachievers and show that they bisect each other. All right. So anything that's either a definition or property of the other figure when you're doing a counterexample is good to go. Okay. Work on those two, please. All right. The one on the left is a parallelogram. The one on the right is a kite. The one on the left is a parallelogram. The one on the right is a kite. All right, everybody good? All right, so now what we're going to do is take a couple minutes to plan or start that proof. You will have one proof on your quiz on Friday. You will have one proof on your quiz on Friday. So, and it'll be 2 columns before that. So it'll be so. If there's more than one, then the other one will be trying to drop it. Plan right now to have one. I think there's enough different things that we only have to do one of them. But I'm going to start writing it today, so I'll let you know tomorrow. If there's a second one, then it will be done. But like I said, as of now, I think there's enough between systems and right triangles, and isosceles triangle. You will. And for you guys, I will be after virtually tomorrow for virtual math library. Okay. Now, basically, they tell us that PULY is a parallelogram. All right, so that angle is congruent to that angle. That angle is congruent to that angle. All right. That side is congruent to that side. That side is congruent to that side by properties. All right. Everybody good? Okay. Now, basically, let's go from there. They also tell us YS is congruent to UN. Is those. All right. To prove a figure is a parallelogram. To prove a figure is a parallelogram. All right. We have to prove either opposite sides congruent. And this is what I mean by planning it out. Opposite angles are congruent. Consecutive angles are supplementary. Opposite sides are parallel. We got a lot at our disposal, or the diagonals bisect each other. Which one of those you think is going to be the hardest to prove? The hardest. I agree. So chances are I'm not going to want to work with that. All right. Now, I'm going to do it with triangles, because that's going to set you up better for the quiz on Friday and Monday. However, if you look at this, if this is a parallelogram, right? Those opposite sides are already parallel. You have to prove these are parallel. Well, there's not really a lot of angles in there yet. That's why I would go with triangles. So, basically the idea is this. Angle LYP is congruent to LUP. Angle LUP. That's given. That's properties of parallelogram. That's properties of parallelogram. All right. Why then is angle LYS congruent to angle PUM based solely on that? So LYS is here, PUM is there. Why are those two angles congruent? What do they form with the other congruent angles of what? Linear pair. And linear pairs are supplementary. So congruent, supplement, theorem, conjecture, property. All right. So those angles are congruent. Do I now have enough to say the outside triangles are congruent? Absolutely. So triangle LYS congruent to triangle PUM. I got two sides and an angle, so that's got to be what? Side angle, side. LS is congruent to PM because of what 5 magic letters? DPCTC. LM is congruent to PS. And we should put the congruent in front. Congruent segments added to congruent segments results in congruent segments. If you want to shorten that out, you can say anything that's similar to that. The sum of congruent segments is congruent. Anything you want, as long as you're getting the right idea. All right, I'll go back in the book to see if there's a formal name for that. All right, I don't recall. All right. Are both pairs of opposite sides now congruent? Yep. So SLMP is a parallelogram, properties of parallelogram. And there you go. Okay. Everybody good? Okay, so tomorrow we'll take, excuse me, any last second questions from virtual and or Acer to their quiz, or anybody who has a question? All right, if you double check tonight, but right now we are going to start polygons in the coordinate plane. All right, polygons in the coordinate plane. Open other presentation. This PC. Polygons and the coordinate plane. Okay. This is not on your quiz. 6.7, you will have your own separate quiz on this, as this covers a lot. All right. You have at your disposal the distance formula, which is the square root of x2 minus x1 squared plus the y2 minus y1 squared. You have the midpoint formula, which is x1 plus x2 over 2, y1 plus y2 over 2. And then finally, you have the slope formula, which is y2 minus y1 over x2 minus x1. Okay. Obviously, the distance formula can be replaced with Pythagorean theorem. We'll talk about that in a second. All right. So basically, the first thing we're going to do is classify triangles. You are going to use the distance formula to find the side lengths. And then number 2, use the converse of Pythagorean theorem to determine if any one of its angles is obtuse or right. All right. So you have to classify A, B, okay. We got to go through this on paper. No worries. Okay. So we're going to classify triangle ABC given coordinates A, 0, 1, B, 4, 4, and C, 7. Should be just 7, 0, not 17. Should just be 7, 0, sorry. All right. So basically what you're going to do using either Pythagorean theorem or distance formula, all right, you're going to find the length of that segment. From 1 up to 4 is 3. From 0 over to 4 is 4. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. Square root of that is 5. So that has a length of 5. So that's how you do it using Pythagorean theorem. All right, I'm going to do this side using distance formula so you can see which one you want to do. All right. How did we? Yeah, okay. So this is going to be 4 minus 7 squared plus 4 minus 0 squared. They can be interchangeable because if you switch the order, you're just going to end up with the opposite number. And when we square opposite numbers, the result's the same. 4 minus 7 is negative 3. 3 squared is 9. 4 minus 0 is 4. 4 squared is 16. 9 plus 16 is 25. Square root of 25 is 5. So that side length is also 5. All right. The last one, AC, from 0 to 7 is 7. So 7 squared. 1 to 0 is 1. So 1 squared equals C squared. 7 squared is 49. 1 squared is 1. 49 plus 1 is 50. That is the square root of 50. Okay, now, if you want to simplify that, you can, but it is not necessary. Because we're just trying to find out if they're the same. So even if radicals aren't simplified, can we tell by looking at them if they're the same length? Yes, so it's unnecessary. Got it? So you do not need to simplify any radicals in this unit. So I have one side that's 5, one side that's 5, one side that's the square root of 50. So these are my choices for my answers. Scalene, where if you haven't seen it before, no sides are congruent. Isosceles, where two sides are congruent. And equilateral. Okay? Equilateral, where all sides are congruent. Since I have two sides that are congruent, that triangle is going to be isosceles. All right? Now the second part is angles. And for that, we use the converse of the Pythagorean theorem. Now, it would be helpful if you could estimate that in your head. So in other words, 50 is a little more than 49, so that's going to be a little more than 7. Why? Because that is, ladies and gentlemen, the longest side. We just want to know which side's the longest. So when I do angles, I'm using the converse Pythagorean theorem. 5 squared plus 5 squared versus the square root of 50 squared. This is the other reason we don't simplify any radicals. Because when I square a square root, what do they do to each other? Cancel out. So that's 50. 5 squared both times is 25. 25 plus 25 is equal to 50. That, ladies and gentlemen, is a right triangle. Recall if c squared is greater, it's obtuse. If a squared plus b squared is greater, it is acute. So your answer, ladies and gentlemen, is either isosceles right or right isosceles, depending upon how you write it and or how the answer choices exist. All right. The only other thing we're really going to do with triangles is mid-segment, and we'll talk about that in a moment. Okay? When I say a moment, I mean a couple days. All right. So, when we classify quadrilaterals, you're going to find the slopes of all 4 sides. All right. 2 pairs parallelogram, 1 pair trapezoid, 0 pairs might have a kite. Fill that in first, and then we'll give you the missing words. All right. The 2 pairs parallelogram, 1 pair trapezoid, 0 pairs might have a kite. Well, parallelogram, opposite sides are parallel. That's the 2 pairs. In the coordinate plane, when lines are parallel, what's true about their slopes? They are equal. So the only thing missing that you got to add is the symbol equal. So 2 equal pairs, you have a parallelogram. 1 pair equal, you have a trapezoid. And no pairs equal, you have a possibility of a kite. And we will tell you when you have to look for a kite. Okay. But that is not all. If you have a parallelogram, find the slopes of the diagonals. Find the slopes of the diagonals. If they're perpendicular, you have a rhombus. Either way, go back and compare the slopes of the original quadrilateral. If they're negative reciprocals, you have a rectangle. All right. If both of the above are true, then you have a rectangle and a rhombus, better known as a square. Okay. Everybody got that? If you have a trapezoid, check the lengths of the non-parallel sides using the distance formula. If they're equal, your trapezoid is isosceles. You can also check the lengths of the diagonals because they would be the same too. If you have no pairs of parallel sides, find the slopes of the diagonals. If they're negative reciprocals, you have a kite. If they're negative reciprocals, you have a kite. And we would tell you to look for the kite. Okay? Because that one's kind of hard because it involves a lot. Okay, tomorrow we'll work on examples of each so you have an idea of what you're doing. Friday and Monday, we'll finish the quiz. All right. The other group will be working on this as well. Tuesday and Wednesday, we'll go over everything, which means next week we'll have a quiz again on just that. All right. Those of you at home can split if you'd like. Have a good day. I'll see you tomorrow. Oh. I can stop recording. There we go.